Good afternoon and welcome to MC4 Software's webinar on how to create a heating and cooling system. We will first input a residential building, which the program can also be used to input a commercial building as well. From there, we will be able to calculate the heat loss and cooling loads that are required, and finally size the radiant heating system based on the heating and cooling loads on the floor. However, the program will also calculate the heating loads and cooling loads for the ceiling and walls as well. As you can see, this program is integrated with HtCad and has several different tabs to choose from, such as loads calculation, hydronic, plumbing, radiant, etc. So to begin with, we'll first start by selecting our location, which we can do so by going to our project settings panel and clicking the icon here labeled location. With our general and climatic data window, we can come over to our database button and left click. With our locations list window opening, we can choose the nation's pull down arrow, and we can choose from our selection of countries. I can also type U for USA. We'll left click. And for the United States, we have all 50 states, including the District of Columbia. We'll select the District of Columbia, and for our demonstration, we'll use the location of Ronald Reagan International Airport. As you can see in the weather data in our right-hand section under General Data tab, we have our location, the nation, the state, which is District of Columbia, latitude, longitude, and altitude. And we also have our temperatures, which are preloaded from our selection. If we left click on our weather data tab, our ASHRAE values for the months of the year as well as the hours of the day have been preloaded. If we left click apply, OK, we come back to our general and climatic data window where our location, our sky clearness, solar reflectance of foreground surface, altitude above sea level have all been filled, as well as our winter and summer conditions for dry bulb temperature, wet bulb temperature both in Fahrenheit, as well as our relative humidity and percentage. We'll click End, and we have our location set. From here, we can go to our database and select our structures. And as you can see, we have nothing in our project tab at this point, so we can go to our database MC4 tab. As you can see, we'll put everything in alphabetical order. We have a large selection of structures to choose from, ranging from ceilings to floors, glass, and walls. We'll choose a 8-inch block R19. We can select In Project to put in our Project tab. We'll also come down to our ceilings, and we can select our ceiling gypsum joist R38 attic. And if we'd like to select more than one, we can select the Control button, and we can also then left click the floor plywood 2x10 joist R19 internal. We can select In Project. And finally, a third option, we can come down to our interior wall, 2x6 metal R-0.1.92, right click, and we also have the option of clicking In Project. If we come to our Project tab, you can now see that we have all 4 of our selections that we chose into our Project tab. Below, for our 8-inch block R19, you can see our image of our wall with our interior and our exterior. Again, with our ceiling, exterior, and interior. If we come back to our 8-inch block wall, under General Data, we have our category, which is our outdoor walls, our type of element. If we would like, we can choose external wall. Our color, we have light, medium, and dark. We'll choose medium. And our 3D colors, you have the option of choosing whatever color you would like. We'll leave it as a default. And if we come to our layer structure tab, we'll move this out a little and also see our description. As you can see, for our 8-inch block wall, it consists of a 2x6 standard 16OC R-19 bat, which is our inside section, which would be here, and our center block 8-inch hollow wall, which would be here. If we would like, we can also add another piece, which would be, say, for instance, a plywood 3/4 inch, and we can just insert it in, and as you can see in our visual, we have it added onto our exterior. If I highlight it and use the up and down arrows, you can see now that it's in the middle, or in our visual in the middle here. If we would like to exclude or delete it, we can just simply highlight it and then click the delete button. The MC4 database window will ask you if you would like to confirm. We'll say yes, and it has now been deleted. If you would like to delete any of these, you can do so in the project tab, but we recommend that you do not delete any of the objects or structures in the database or database MC4, which will be permanently deleted. So if we click apply, OK, we can now go ahead and select our floor levels, which can be done so in the project settings panel by clicking this icon labeled levels, or we also have the option on the commands window, building step by step, and clicking level list. Again, as you can see, we have nothing in our project tab, but if we click on the button new, we can go ahead and label our level. In this instance, we'll call it main, and we can select OK. As you can see in our level characteristics, we already have our description, our precode, our height, and if for our height, if you like, we can make it larger or smaller, however you would like. For our ceiling, we now need to select a structure. By clicking a down arrow in our project, we already have selected from our previous structures database the ceiling gypsum joist R38 attic. So by double clicking, we have now selected our structure. We also need to select an exposure, which we can use as calculated or conditioned space. For instance, we'll choose conditioned space. And now we'll do the same for our floor. For our exposure, we can also go to our database MC4 tab, and we have different options to choose from. For instance, we'll choose the slab on grade with an R10 insulation. The RFH data, we'll need to choose a floor covering. We don't have anything in our project, so we'll go to the database MC4 tab, and as you can see, we have different types of tiles, carpeting, hardwood floors, limestone, marble, etc. We'll choose the carpet acrylic level loop 1/4 inch. And finally, or actually we'll need to go to our radiant system next and choose the database MC4. And if we would like, we can use our filter command by enabling the box. And for our demonstration purposes, we'll use Viega for our radiant system. We'll use the slab on below grade 12-inch slab 1/2 inch Viega PEX barrier. We'll double click. And then finally we have our final two pull downs, which are fixed occupied spacing and fixed perimeter zone spacing. These are in inches, so if we'd like, we'll choose 6 inches for our occupied, and we'll also choose 6 inches for our perimeter. At the bottom, we have options, which is our elevations we'll leave as default, but if you'd like, we can choose the different elevations by using our up or down arrows for both our building elevation and our ground elevation. And finally, our last tab, labeled elevations, you can see how our structure is broken down into dimensions. We'll select apply and OK. Now we can go ahead and insert our XREF, which we can do so by going to our XREF panel and selecting this icon here labeled DWG, or we can come down and select our insert XREF under the building step-by-step sidebar. We'll choose our first floor. We'll open. And now we can put in our dimension, our XY value of where we would like it located. We'll select OK. And as you can see, we now inserted our XREF. We can now come to our units of measures, which we can do so in a project settings panel here, or also in our projects navigator sidebar measuring unit pull down, and select modify. In our display measuring units window, we'll select imperial units, but you also have the option of international system. But for the United States, we'll use the imperial units and come down to scale. We'll make this bigger so we can see. And as you can see, our description is scale. Our unit of measure is an inch, but you can also use different types of measurements such as feet, miles, meters, yards, etc. But we'll use inch. Our accuracy, we have different types of accuracy, and in our demonstration we'll use to the nearest hundredth. And finally, our rounding, we have to the nearest 0, 5, 10, 50, or 100. We'll use to the nearest 0. We'll click apply, OK, and finally we'll come to the scale factor, which we can do so here in the project's settings panel, or also once again in our building step by step, use the scale factor button there. We'll come into a known dimension, which is 2 feet or 24 inches. It asks to enter. We'll confirm. And now we have confirmed our scale factor of our drawing. We'll just turn off our text and our dimensions so it'll be easier to see. Click OK. And now we're ready to insert our walls. First, we can insert our exterior wall, which we can do so in the external panel, and convert line into external wall, or again, building step by step, transform entity into external wall. We'll use this icon here, and we'll extend this. And under Structure 1 data, we'll need to select a wall structure. By using the pull down, we have the option of the 8-inch block or the interior wall. Since this is an exterior wall, we'll use the 8-inch block. By double clicking, we'll zoom in and left click on the interior section of the exterior wall. And we will just highlight portions of the wall, which will eventually use the fillet command, which I'll do here now, use the fillet, with a radius of 0, and we will make all the walls with a 90-degree turn. And if I use the line weight, as you can now see, we have successfully drawn our exterior wall. Now, it's the same process by going to the external panel and clicking convert line into internal wall, or again, building step by step, transform entity into internal wall. And we can now select the wall structure by clicking on the left pull down arrow and click interior wall 2x6 metal. Double click, and we'll zoom in and left click, and as you can see, the program has automatically offset the interior wall to the center of the DWG XREF file. If we have the cursor up to the outside of the interior wall, you can see it's on the wrong side. If we type the letter S for switch side, it has now switched it into the proper location. So we can type S again, it switches, and we can do so for the remaining of the interior and exterior walls. And type S one more time. And once again, use our fillet command with a radius of 0 to connect the rest of the remaining interior wall sections. And after we have our fillet command, we have an excess wall section here, so we can just highlight and delete. And then we use the extend command to extend the final portions of our interior walls so we can create our rooms. So if we extend, 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 and our final one here. If I left click to highlight the exterior wall, you can see when the interior wall has been extended to the exterior, the interior wall has actually separated the exterior wall into two different lines. So if I use the line weight button here, you can see now we have all of our rooms created. At this point, we can go ahead and come back to our database panel here and select Windows, or again in our building step-by-step, come under Databases and select Windows. With our Windows library window open, as you can see, we have nothing in our Project tab. So we'll come to our Database MC4 tab. And as you can see, we have several different types of windows and actually glass doors to choose from. We'll actually choose the one-slash window for our project and simply click in Project. We come to our Project tab, and as you can see, we successfully inserted the one-slash window. We also have different tabs over here to choose from: construction, thermal, solar, dimensions, and acoustic calculation. And for our one-slash window, we have the option to, for instance, under window specifications, choose a manufacturer if we would like. If we'd like to choose Viega, or from our database MC4, choose another manufacturer. If we extend this, the number of window wings, we can use the up and down arrow to put in this number of sections that we'd like. If we'd like to create this as a double window, we can enable the box or not. We also have the option to make this a rectangular shape or an arc shape. We'll choose the default, which is rectangular. We also have the option to increase or decrease the frame thickness, which is in inches. The horizontal subdivision, which again, we can use the up and down arrows to create how many we would like. There's also a fan light, the wall above the window, the section, the type, which will create as 8-inch block. The height we'll just use as a default, and the wall under the window will also use the 8-inch block. If we'll also like to choose a roller shutter container, we can do so by clicking on Standard and then just typing in what the height would be in feet. So we'll type in 1/2 foot, and as you can see, after confirming, here is our roller shutter. If we come to our thermal tab, we have our different sections under the description. We have the window U value, the window thermal transmittance, our glass, for instance. In our glass, our source, we can go by standard. And under description, choose the wizard icon. And then we have a type, double glazing or triple. We'll choose triple. Next, we'll have our different types of glass. We can have an uncoated glass or 2 panes coated glass with different types of emissivity, and we'll choose the latter here. Click Next, and the type of gas space that is in our windows. We can choose from air, argon, krypton, SF6, or finally xenon. We'll choose air with a value of 0.176, and we'll select OK. And the type of glass, we can choose single, double, or triple glass. For instance, we'll just choose triple. Our frame, we can also go by clicking the wizard icon. And we have the option to choose different types of hardwood, softwood, metal with a thermal break, polyurethane, or a PVC. We'll choose the softwood here. And with our roller shutter container, again, we can have the option of a non-insulated or an insulated roller shutter container. We'll choose insulated. And with our solar tab, as you can see, we have different sections again. We can choose for instance here, the glass plus shading factors. And again, we have different types to choose from. We'll select a value of 0.4. We also have the dimensions. Again, the dimensions we will leave as the default, but if you'd like, we can actually increase or decrease by using the up and down arrows. And finally, the acoustics calculation. Since this is not a noise CAD drawing, this section will be left blank. We can finally click Apply and OK. We can now go to our external panel and actually insert our windows by clicking on this icon or coming down into our, there it is, our building step-by-step draw window. We need to select the window type. Since we only selected one window, which is the one/window, we can now simply zoom in and left click, single left click, and as you can see, the window has been automatically inputted into our drawing with this generic dimensions. We can use the grips to either extend or shrink the window. We can also have another option to insert it by right-clicking and then coming down to 2 points. The 2 points is where you can left-click once, left-click a second time, and you automatically put in where you would like the window to be with your own desired dimensions. So if I continue using the 2 points command to insert our windows, I can quickly go around and insert our windows. If I accidentally miss the exterior wall, our MC4 warning label will come up telling us to select a wall on the current level. I'll select OK, and now everything is back to normal, and our final window here. So now we have our windows inserted into our drawing. After this, we can now need to create our zones and units, which we can do so in our building units under the building step-by-step, or also in our project settings panel, which is this icon here labeled zones for our internal design conditions. As you can see, we have our unit zones list window, and we don't have a unit selected yet, so we can just select the button here, add unit. And for a description, we'll label this as unit-1. And if we'd like, there's a pre-code that we could add, and numbering, properties, exposure between units. We'll just leave them as default and go to our Radiant System tab. We'll need to select the manufacturer, and in this case this is Viega. And 2 additional tabs appear underneath, a Radiant Systems tab and a Building Systems tab. Under Radiant Systems, we have Design Criteria, which we have the option of choosing a cooling or heating base sizing and heating verification or cooling verification. We'll leave it as the default. And then the predominant system, which in this case is floor, but we also have the option of choosing a wall or a ceiling. And a type of system, it's either going to be embedded or precast modules. We'll leave it as embedded. And our secondary system, we'll leave it as wall, which is our only option. And again, our type of system, embedded or precast modules. If we finally come to our buildings tab here, we have it broken down into building, in this case, Viega residential, but as I said in the beginning, we can also use this as a commercial. We also have our general data, manufacturer, project specifications. If we select the button here, we have our maximum limit temperatures, our minimum limit temperatures, supply temperatures limited for heating, as well as for cooling. All these temperatures have been preloaded because of our location of Ronald Reagan International Airport that we have done earlier. So after our unit has been created, we now have to create a zone, which we can do so by clicking Add Zone. We'll label this as Zone-1. And our type of zone, we have 3 different options. The air conditioning, which is heating and cooling, only heated, or not conditioned at all. We'll choose the air conditioning. And then with our internal design conditions, we have our temperatures and our relative humidity, which have been already preset because of our location. And then our air infiltrations, which is the number of air changes and number of air changes per person. If you would like, we can change these by just typing in new numbers. If we go to our Systems Data tab, in our top section, we have to choose a type of system. In our demonstration, we will choose a radiant heating system, so we'll enable the box. And under the description, we need to choose our system data air movement index, which we have several different options to choose from, and we'll leave it as our default. Our working schedule code we need to choose from our winter and our summer, which we can do so by our database MC4, which we have the option to choose always on or warehouse heating and cooling. We'll choose always on for both our heating and summer. We can finally go to our last tab, our internal loads, which is broken down into 3 different sections, our people, lighting, and appliances. As you can see, our values have already been preset because of our location for sensible latent and occupancy, but we do need to type in a time profile percentage. And since this is under people, we'll come down to our people section and we'll have this as people hotel guest room. Double click. For our lighting, we'll do the same and we'll choose lighting hotel guest room. And for our appliances, for a time profile percentage, we can actually just go ahead and select cooling only. We'll select apply and OK. And now we have set our building units for our internal loads design. Now we can insert our rooms, which we can do so under the building step-by-step side panel by clicking this icon, or come to our internal panel and select room. First, we need to select which zone we're in, so we use the pull down and select our zone 1. For our description, we can select kitchen, which this will be our kitchen here, and I will left click inside our kitchen area. A label has been set up, and as it is broken down into code, our description, which zone we're in, and the area. If I come to an isometric view, you can see that the program has a 3-dimensional view of our kitchen. The green lines representing our internal walls, our cyan color representing our external walls, our yellow representing our ceiling, and finally red, which is representing our floor. You can see where our windows are located as well. So we'll come back to an overhead view and finish out putting in our rest of our rooms. We'll choose our corridor. We can choose our half bathroom. Choose a closet, which will be here. Dining room. Entry. And finally, we'll choose family room. And again, if we come back to our isometric view, you can see that all of our rooms have been designed and set up. Now at this point, the program recognizes the top of the screen as north. If we don't put a north arrow in, that's what the program will decide. But if we come to our project settings panel, select north, we can simply left click, put for position, and then a second left click for our rotation, or simply type in an angle, for instance 45. So now our system recognizes this is the direction for north. We can now, at this point, set our first round of calculations. We can put our heat loss calculations in by coming to our building step-by-step calculation, which it can also be done so in our loads panel, which is also here. And as you can see, it says our statistical value. Here's our results for our main calculation results for heat loss summary. Our heat loss in BTUs per hour is 7,146. If we come to our statistics, and we'll add a legend here at the bottom, you can see that if I have the cursor hovering over the green arrow or green bar, it is the 1/ window, and you can see that it says the heat loss is 591 BTUs per hour. Our exterior wall, the 8-inch block, has a heat loss of 742 BTUs per hour, and for ventilation, 720 BTUs per hour. If I come to this button here, you can see that represented in a pie chart form, broken down in percentages. And again, with the cursor hovering over each pie section, you can see the actual value of how many BTUs per hour there have been lost. So if I come back to the Results tab, click Close, we can now also go to our cooling loads, which we can do so under Calculation here, or come under our Loads panel and select Cooling Load. We had the option to choose from which month, so we can choose from January all the way to December, but in this case, typically the hottest month of the year is July, so we'll just use from the beginning to the end of the month of July as our cooling load. After a few seconds, our program calculates the cooling loads, and as you can see, it's broken down into cooling and heating. Max heat extraction rate for BTUs per hour for the rooms is 15,085.5. The peak hour is 6 o'clock in the evening, and since we chose July as our month, that is our peak month. And again, for heating, our max heat extraction rate in BTUs per hour is 7,146.3, which is also our total for both our heating and cooling as stated here. We'll click Close, and now we're officially done our Loads Calculation tab. Our next section we can go to is our Radiant tab, and as you can see, we have a new selection of icons to choose from. We can now go to our pipe project, and our pipe project list window opens. As you can see, we don't have anything currently in our project tab, so we can click the New button, and our new piping system window opens, and we'll need to name our new pipe project, which we'll call Radiant. Under our system type, we have several different types to choose from: thermal, plumbing, gas, fire protection system, double phase fluid, and mechanical room. We'll choose thermal for our demonstration, and for our supply and return system fluids, we can click on the down arrow and click on the Database MC4 tab, and you can see that we have many different types of water or fluids to choose from. We'll choose 40 degrees Celsius, which is equivalent to 104 degrees Fahrenheit, for both our supply and our return. If we would like this to be a schematic drawing, we can enable the box. If not, we can enable the box. We'll enable it for a schematic drawing and select OK. And now you can see that in our project tab, we now have our Radiant pipe project. And as you can see over here on the right-hand section, the system type is thermal, it's schematic. If we'd like to, we can choose the designer, but it's not necessary at this time. Under the design data, we have our fluid, our spacing in inches. If we like it fixed, we can enable the box here or not, as well as if we want to use a pipe as a bypass, again, enabling or not. We have our source temperature and insulation bill of material calculation. We also have two separate tabs down here, fan coils and radiators. Our fan coils, for instance, we have the option to choose the type of terminal, 2-pipe or 4-pipe, calculation type, We have our Summer Choice Plus winner or Summer Selection verification. We'll choose the Summer Selection Plus winner. Our fan speed, which is low, medium, and high, as well as our water flow, air movement, and max delta P. We also have other sections to choose from, such as our safety increment, a minimum delta T, intake air, entering water, and primary air conditioning. Primary air contribution. Again, most of these values have been already preloaded because of our location that we have chosen. And finally, our radiators tab, we have, if I have it here, our internal design temperature in Fahrenheit, our water medium temperature in Fahrenheit, delta T in Fahrenheit, safety increment, as well as our primary air contribution in percentage. If I click apply and then OK, we have now successfully created our pipe project. At this point, we can now go to our right area panel and select a right area extraction automatic. If I come over here to our sidebar, as you can see, I have an option to choose what type, allowed or forbidden. We'll use the default of allowed, as well as different options such as fixed z-coordinate or z value in feet, the distance from circuits in inches, floor type, pipe spacing, and distance from perimeter. We also have different options under area and our layouts, such as layout patterns. We can have a counterflow, serpentine, double meander, or unspecified right area. We choose counterflow, and directions, for instance, not specified, clockwise or counterclockwise. If I come back to our drawing and select the room label, I simply left click, I'll escape, and you can see a green label has been produced, which is our right area label. As you can see, we have our code, our room area, our covering, which is our carpet, our exposure, which is our slab on/below grade. We have our warning, which says our circuit drawing is not updated, which will disappear when we add our circuits later. And it also has our radiant area in feet squared. If I also zoom in and select the right area line, you can see we can see that it is a dashed line which represents it is our perimeter. If I also come to our extended data, as you can see, let me extend this, our floor type, which is perimeter. If I select the right area line for an internal, there we go, it is a solid line, which is represented as an occupied floor type. So typically we have our external walls will be dash and our internal walls would be solid lines. So if I come back to our right area automatic label, will simply left click on each of the room labels. Nope, missed that one. And I will just now simply drag them so it's more aesthetically pleasing. Okay. So now we can see that we have all of our rooms now have been created with a right area label. If I come into our kitchen area, eventually we'll put in our circuits here shortly, but our circuits we would only want in this area. We don't really want our circuits in our cabinetry area where our sink, stove, dishwasher are. So I can actually also use our draw right area manual drawing icon. And if I like, I'll choose a perimeter. And I'll simply left click on the ray area line. And what I'm going to do is just outline where our cabinetry area is located. Enter. And now I have drawn a manual ray area line, which you'll see here in a few minutes. When I insert the circuits will fill in this area here and will exclude our cabinetry area. So I'll zoom out. And at this point, with our ray area, we will now go with our second round of calculations, which will go ahead, heat loss calculations. They should be the same. We'll close. We'll do our cooling loads. Again, we'll select OK and close. And now we can come to our zoning area. Actually, before we go there, we'll actually need to first put in a manifold. I will go to our manifolds. And as you can see, we have nothing in our manifold or in our project tab. So we'll go to our database. We'll choose our manufacturer. We'll choose Viega. We'll use our filter system. And we have all of our Viega manifolds to choose from. We'll choose the shutoff bouncing and flow meters. Select in project. And as you can see under the general data tab, we have our description, our manifold type, which is hydronic system, diameter, class, manufacturer, our long description of our manifold, and abbreviation. Under the hydronic or plumbing distribution manifold, I'll extend this. We have different sections such as our drawing values, which we can choose for drawing type of type 1 or type 2, our manifold diameter, single manifold length, etc. Different types of blocks that we could choose from, our connections, connection valves, and manifold cabinet. At this time, we'll just leave them as default and select Apply, OK. Now that we have our manifold selected, we need to actually reselect it under our command sidebar window. We can, for our distribution line, we can choose either supply or return. We'll select supply. Our type, we'll choose the shutoff balancing flow meters that we just created. Our number of exits, we can use the up or down arrows to choose how many exits we would like. We'll choose 4 at this time. And for the height from the ground, we'll type in 3 feet off the ground. Our project information for our pre-code, we'll just label it M for manifold. And we can just zoom in and now simply left click once for our position and a second left click for our rotation. Now with our label, again, 2 clicks will insert it. So we have our 1, 2, 3, 4 exits for our M1 manifold. We'll come down here near the entry and we'll insert our second manifold. And again, if that's not the exact location you want, you can just simply use the move command and move it where you would like. So after we have our 2 manifolds inserted, we can go to our zoning panel, and now we have to associate our radiant area to their rooms. So for instance, we need to associate this manifold with our kitchen area. So if we simply left click on the green label, right click or enter, you can see that the area of the kitchen has been shaded, signifying that the M1 manifold is now associated with our kitchen. So if I simply left click again, I can come out and do the same for our dining room. I can also click on the label itself and not the actual manifold, and left click again, and we had the same results. So again, left click on the label, and now we have the M1 manifold will represent or be associated with these 4 rooms. The M2 manifold down here, I can associate with the remaining 3 rooms. Okay, so now that we have all of our rooms associated, if I'd like, I could turn off these by coming over to our Project Navigator sidebar window under the Radiant Heating System tab. I can turn on and off the highlighted area by just disabling or enabling it. Now we're actually ready for our second round of calculations, and we can do so again by our heat loss calculations. I select close. Our cooling loads calculations, I'll select OK and close once more. And now I can go to our zoning panel and click on the design temp. If I left click, you can see which rooms have been associated with which manifold. If I left click here, you can see under kitchen, I have the array area, which is broken down into different types of layouts and project information. And also you can see down below, this is the number 1 kitchen, where this is where our circuits will be drawn, and our kitchen 0, which would be here, which is where it's going to be excluded. Our most demanding area is actually our entry, as you can see down here. And we have our different columns, such as our area, pipe spacing for occupied, pipe spacing for perimeter, number of circuits, room load for BTUs per hour, load density, residual load, delta T, our floor temp, flow rate, length medium, tails, and finally our delta P medium. Since we would like our residual load column for our entry room to be close to 0, which it is, this will give us a better calculation. For instance, we can modify this by using this bar to slide either to the left or the right to make our design temperature range either higher or lower. Or you can simply type in a value, which in case we'll use 104 degrees. We can now simply select OK. And now we're ready to put in our circuits. Our floor type we'll choose as occupied. And I can zoom in, and I would want to left click on the array area line, the green line, so I can insert my circuits. As you can see, I have excluded, the circuits are excluded because of the manual array area that I have drawn. If I type T for turn, I can turn the circuits whichever way I would like. I'll choose this way. And also with the arrow, if I type D, you can see the arrow changes the directions either to the left or to the right. I'll choose to the left, and now my circuits have been drawn after I do a second left click or enter. They have now been drawn. I'll repeat this command. And now I have drawn circuits into these 3 rooms, our family room, living or dining room, and kitchen. I can also have the option of actually creating a circuit path where I will left click on the array area line, and I will come up, and it's just like drawing a line. I'll come into our stairwell a little, come out, and what I am doing is I am going to exclude our stairwell here of having any circuits drawn. So very similar to what the manual array area command was like, but this time When I draw, I can come to this icon here under the circuit drawing, which is labeled circuits, and I will simply left click on the cyan colored line that I just drawn. And as you can see, the circuits are drawn where I wanted it to be drawn, excluding the stairs. We can now go to our tails command, and we can now draw our tails into our manifold. So if I left click on the cyan colored line, and I'll left click, I also have the option of selecting occupied, perimeter, imposed. I will choose imposed, and the distance from the circuits will be 0. I'll left click and enter, and as you can see, the circuits have been drawn in. I'll do it one more time. I'll left click on the icon, choose occupied, come out. I'll once again choose imposed with 0 distance to the circuits, left click, and now I have drawn my tails coming through the entryway. And I'll do this one more time for our M1 manifold. As you can see too in our label, the number 5 here, this represents that there's going to be 5 tails coming in. So we have the red and the yellow, 1, 2, and then we also have green, North Carolina blue, and Duke blue for our remaining 3, so 5. However, we have only 4 exits. If I highlight the manifold, come to our extended data, and the number of exits, I'll just simply increase it by 1 and click apply. And now you can see that we have 1, 2, 3, 4, and 5 exits. So if I go ahead and left click on the tails, occupied, choose imposed with 0. Now we got our room full of tails that will occupy our closet, and finally we'll choose our dining room, which again occupied 0.8. We'll left click and one last time imposed with a 0 distance for the circuits. Now we have successfully drawn our circuits into the manifolds. So we can now, after we have our drawing completed, we can do one last design temp calculation. And again, if I select the down arrow here, we'll make sure that everything is fine. We have our residual load, it's still 0. We have our room loads calculations, our load densities, residual loads, delta T's, and so forth. I can then go and click OK. And now we're ready for our reports. We can go to our reports panel and click on Radiant Report. And we have the option of technical report long or short. In this case we'll choose short, select OK. We have a language to choose from. We can choose Italian, British English, Spanish, French, or American English. We'll choose American. We'll need to select where we would like to save our report. We'll call this Radiant DC. We'll select Save, select OK. And since we save this as an RTF file, in a minute a Word file will open. And as you can see, it's radiant floor heat analysis. We can fill in the information by type of project, project description, client location, etc. And page 2, we have our notes. At this point we have none, but you can fill in whatever notes you would desire. And now we have it broken down into project details, such as type of building. If you'd like, we can type in residential. Also has our total pipe required in feet, which is 1,668.03. Our system's capacity in gallons, fluid type, or how many manifolds we have, our total radiant area, and also our heating and cooling, which is broken down into radiant output, supplemental heat, and BTUs per hour, nominal boiler output. Come down to our next section, our manifold summary. We have two different manifolds, M1 and M2. Our supply temp for heating and cooling, our flow rate circuits, how much of the area is covered in feet squared, our heat loss, quantity of rooms that it's supplied by, total heat rate, and finally total cooling rate. Excuse me. We have our rooms detail, which again, we have our rooms listed on the left-hand side, again with our other columns such as heat load, heat flux, residual heat, cooling loads, etc., with all their values listed below. And that is our print report for our short version. We'll save. And finally, back into our reports panel, we can now list our bill of materials. By clicking the icon, I can name this, we'll call this BOM for bills of material radiant. And for the piping system, bills of material characteristics, I can select the unassembled fan coils and radiators. For projects to apply, well, since this is thermal, and for our radiant system, we'll choose the Viego Unit -1 and then select Create Bill of Materials. We'll enlarge. As you can see, for our list of materials, we have our MC4 description, which are listed in this column here, if they're fixed. Our types of units, which are feet. If I use the pull down arrow, you can see it's in pieces, our volume, different types of volumes, inches, any type of unit you would like. Our pricing list, measuring unit, in this case we have it in feet or by piece, the packaging, and also our number of elements. For instance, if you wanted to locate the manifold in our database, which is this window over here, I can simply click in the code, type 15056, and then click on the 3 button icon. Search was not found. But if I click on there, we can eventually find where it is there. If I come to the print icon, actually before I go print, I can do the print list, and you can see we have our code, our description, unit of measure, and our price of each one. If I come to the estimated bill of materials, I'll extend this, extend it a little bit more. We have our code, description, our packages, how many are discarded, and our price with our total quote, considering minimum purchase quantity. Here's our net total. And also here's our net total for estimated bill of materials, not considering the minimum purchasable quantity. But if I come back to the bill of materials tab, I'll select the down arrow for print, and we have the option of choosing RTF or an XLS file. We'll choose the RTF, and we have a short and full or only short. We'll choose the short and full. And if we like, we have the option to display prices, display the VAT or tax, the package quantity, and show images. So select OK. We can select our language. Again, we'll choose American. And we can choose Radiant BOM for an RTF file. We'll select Save, OK. And the Word file, RTF saved, is bills of material. Again, we can modify our type of projects, our project description, as well as others. And then you also have the option of creating your own design notes or comments. In this case, we have them both as none. And then under our chapter radiant heating system, we have our subtotal, which is the price of $4,337. And then we have, for instance, our code broken down, which is 11427, which is the article of the Viegapex barrier by 500 feet. And we have our unit of measure, which is in feet. The number 500, unit price is 89 cents. And our total price for all of them, which is 442.68 cents. As you can see, we have all of our different materials that we have listed. And finally, we have the amount without the VAT or tax, which is 4,337 cents. And if we had a VAT, the total price would be listed here. And finally, our total price is the same as our amount without VAT, which is 4,337. So if I exit, and I can exit here, save, yes. And that concludes our demonstration of how to create a radiant system project.